Imagine 10 ducks on a pond, and in the bushes, imagine 10 hidden hunters. Now the 10 hunters shoot at the ducks, simultaneously and without talking to each other first. Let's think of what could happen. Well, all the hunters could shoot at the same unlucky duck. So that one would be very dead and the other 9 alive. You certainly agree, this outcome will be very unlikely. It is also very unlikely that all the hunters choose different ducks, so that all 10 would end up dead. Hi, this is Chris from Labtastic, and today I want to talk about probabilities and how one can use AI to calculate them. The probability of the two mentioned cases can be easily calculated. Let's give it a quick look. The probability of a so-called Laplace experiment is defined as the number of favorable outcomes of the experiment divided by the number of all possible outcomes. Now let's first look at the case where all hunters aim the same duck. They could all shoot the first duck, all shoot the second duck, the third, and so on. Hence the number of favorable outcomes is 10. What is the number of all possible outcomes? The first hunter can choose among 10 ducks, the second hunter too. So for each choice of the first hunter, there are 10 possible choices for the second. So it's 10 times 10 equal 100 possibilities. For each of these 100 possibilities, the third hunter can again choose among 10 ducks. That brings us to 1000 choices. Do you see the pattern? The number of all possible outcomes is 10 to the 10th. This way to reason is called variations with repetitions. Let's look at the second case, where all hunters shoot at different ducks. The possible outcomes are again 10 to the 10th. The favorable outcomes are 10 factorial, which is 10 times 9 times 8 times 7 times 6 and so on. That's also easy to figure out. Try it yourself. Now, that was easy. Both probabilities are tiny as expected. Now, however, I've got one more question for you that is quite difficult to find an answer to. What is the probability that after the shooting 5 of the 10 ducks are still alive? I tried very hard to find an answer to this question, but in vain. At the end, I came up with a very different approach, a Monte Carlo simulation. How does a Monte Carlo simulation work? Well, basically you make a simulation of the phenomenon or problem you're interested in, usually on the computer. You run this simulation over and over again. Every run gives you a different outcome. After running the simulation many times, you look at the statistics of the outcomes. By doing so, you can get an idea of what is likely to happen on average. Let's try this with our ducks and hunters. In order to do so, we have to simplify the problem and translate it into a language our computer understands. First, let's number our ducks and let them line up in a row. Now let's forget about the fancy drawing and just deal with the numbers. What could a possible outcome for a simulation be? Let me write one down for you. Okay, dead, alive, dead, alive, dead, and alive. That's one way. Or for example, alive, dead, alive, and dead, and so on. You know what? Let's forget about the A's and the D's and instead use 1 for a live duck and 0 for a dead duck. For example, 1, 1, 0, 0, 0, 1, 0, 1, 1. That's a 0 and 1. Now, the number of the surviving ducks is just the sum of all the numbers in a row. For example, 1, 1 is 2, 3, 4, 5. That's 5 surviving ducks in this run. Now we need to generate a large number of such random outcomes, 1,000, 10,000 or even more. And that's exactly where a computer comes in handy. I want to let a Python script take care of the simulation. I'll ask ChatGPT to write one for me. I just have to give it a good prompt. Please write a Python script with the following steps. Create an array with 10 elements. These elements will hold the 10 ducks. Fill the array with ones. Each one will represent a live duck. Create a counter named 5 alive. This counter will be used to count how often exactly 5 ducks will survive the shooting. Now choose 10 random elements of the array and fill them with zeros. Repetitions are allowed. Now that is the shooting. The 10 hunters shoot at the 10 ducks without talking to each other first. So it can happen that one duck is shot by more than one hunter. That's why repetitions are allowed. The ducks are ones, which when they get shot turn to zeros. So a zero is basically a dead duck. Now sum up all the numbers in the array. Sum up the ones and the zeros. Now the sum will correspond to the number of live ducks, and we want this number to be 5, exactly 5. If the sum is 5, increase the count of 5 alive by 1. Now if after the shooting exactly 5 ducks are alive, that's good for us, that's the event we're interested in. Repeat the steps 2 to 5 1000 times. Now that's our loop, that's how often we want to run our simulation. Last but not least, print out the value of 5 alive divided by 1000. That's the calculation. That's the relative frequency of the event we're interested in. Now let's copy this prompt and paste it into ChatGPT and see what it makes of it. If you want to try it out yourself, you find the prompt in the video description below. Okay, thank you. Now let's copy the code and execute it. I'll use Google Colab. Okay, let's paste the code and give it a look. Looks good to me. Here's the creation of the counter. That's the loop that goes through the single runs. Here is the creation of the array with the 10 ducks, all set to 1 at the beginning. Then here is the shooting, the selection of the ducks that are going to die and the death of the ducks. Then at the end, the sum of all the numbers in the row is calculated, and if it is 5, the count of 5 alive is increased. That's the final calculation of the relative frequency of the event we are interested in. You know what? Before executing the code, I'll make a slight modification. I'll reduce the number of the runs to, say, 4 and add one single line here. I'll write print array. This way I should be able to see the outcome of 4 of the shootings. Let's try. Okay, and here it is. I see this shooting had 3 surviving ducks, so that's not the event we're interested in. The next one had 2, next one had 2 again, and that one has 3. So no wonder that 5 alive divided by 4 is 0. Okay, let's get back to our code and this time make it, say, 10,000 runs. 10,000. And here as well. And let's get rid of this line. Okay, once again, executing the code. Now 5 alive is 0.13, so that's more or less 13%. Let's increase the number further to see if this relative frequency is stable. Again, now it's 12.87%, so it's quite stable. That's the probability of the event that 5 out of 10 ducks survive the shooting. Now I'm curious to see what Google Bard would do with this prompt. Let's find out. Okay, Here is the code. Let's copy it and paste it into Google Colab. Okay, here it is. Big moment. Let's execute it. Oh, that's clearly wrong. Now I guarantee you this was not on purpose. However, I do like the surprise. It clearly shows me that the time is not yet ripe to blindly trust our little artificial helpers. Better learn coding yourself. And if you do so, I'm sure you'll soon notice what mistakes Bart made.